Hi, and welcome to our GitHub page on modeling irreversible soil degradation and rehabilitation with the Preisach framework, which accompanies our article on modeling irreversible soil degradation. In this video, we'll discuss some of the resources available in the repository, which are designed to supplement and enhance the materials in the paper itself. We'll start off with our widgets. The first widget focuses on geometric interpretation of the Preisach framework. And in this widget, we demonstrate what hysterons are and how hysterons can be used together to model hysteresis on a system level. So to use the notebook, you just need to click on Launch Binder, and you'll be taken to a page that looks like this. It takes a second or two for the notebook itself to actually load. So in the interest of time, I've already preloaded everything, and we can just go to the notebook itself. Once you're here, you need to click on Cell Run All to run the notebook. So Cell Run All, and then our widget will load. Here we see that we have three hysterons, hysteron 1, 2, and 3, together with our limiting triangle and a graph of output against input. And with this widget, you also have a slider where you can change the value of the input, and we can start moving that along. And what we see is basically how different hysterons, depending on their alpha and beta values, will respond to changes in input, how that affects the portion of the limiting triangle that's shaded, and how that therefore affects the graph of input against output. If we click on Reset or Start here, we can send everything back to the beginning. We also notice that the location of the hysterons is randomly reallocated. So that is the purpose of that widget. The second widget that we have focuses on the weight function. And to run the widget, we just click again on Launch Binder, and we'll be taken to a page. After it loads, it will look like this. And we can click again, Cell Run All to run the widget. If you remember from the paper, the purpose of the weight function is to allow us to account for soil-specific differences. It allows us to have different shaped hysteresis loops. And in this widget, we have, again, a limiting triangle. We have a weight function here with heavy weights and light weights. We can actually add another weight function for the purposes of comparison. And then here on the right, we have a graph of output against input. And we can start, again, by moving around this slider. And we can see how, as we change inputs, the two different weight functions produce two differently shaped hysteresis curves. So that is that widget. And finally, the last notebook that we have focuses on finding the soil's weight function given experimental data, as discussed in the paper. And in this widget, basically, we take the reader through how, using experimental data that's already been collected, one can calculate the weight function. We show how you should go about importing a CSV, how you can reproduce the forks that you've already measured, and then how the weight function can be calculated based on that data. We hope you enjoy the GitHub repository, and with any questions, we encourage you to be in touch. Thank you very much for visiting.